Hello friends, welcome to SSP Math. Today we are going to start last topic of this unit, that is partial differential equation of higher order with constant coefficient. Before this we already solved some problems on linear differential equation with constant coefficient, and now today's our topic is partial differential equation with constant coefficient. So topic is similar, only difference is that is ordinary linear differential equation with constant coefficient, and this topic is partial differential equation with constant coefficient. Means in that differential equation number of independent variable is only one, and in partial differential equation more than one, that is say x and y. Okay, now what is this partial differential equation of higher order with constant coefficient? So suppose if we consider here a0 dA raised to nz upon dA x raised to n plus a1 dA raised to n minus 1z upon dA x raised to n minus 1 into dA y plus so on plus an dA raised to nz upon dA y raised to n is equal to f of xy. So here if we use capital D is equal to dA by dA z, means capital D is equal to dA z by dA x, means this capital D is equal to dA z by dA x, d dash is equal to dA z by dA y. जैसे हम लीनियर डिफरेंशियल इक्वेशन में यूज करते थे डिफरेंशियल ऑपरेटर कैपिटल D is equal to d by dx, same here we have to use capital D is equal to dA z by dA x and d dash is equal to dA z by dA y. So if we use this substitution here, then we will get this differential equation in the form of a0 d raised to n, because here only dA raised to n z upon dA x raised to n. So capital D is dA z by dA x. If we take power of d is n, then we will get d raised to nz upon dA x raised to n. So a0 d raised to n plus a1 d raised to n minus 1 into dA z by dA y, that is say d dash, plus so on plus an into d dash raised to n z is equal to f of xy. Or we can write this differential equation in the form of phi of d dash into z is equal to f of xy, where this phi of d dash is a polynomial in terms of d and d dash, and d is dA z by dA x, d dash is dA z by dA y. a0, a1, a2, an are all constants. So such type of differential equations are called as partial differential equation with constant coefficient. Now how we find solution of equation 1? So solution is same as linear differential equation with constant coefficient. So what is the solution of complete solution of linear differential equation with constant coefficient? We already seen in unit number 4 that solution was y is equal to complementary function plus particular integral. Why we take y in that case? Because y was dependent variable and x was independent variable. In partial differential equation z is dependent variable, x and y are independent variable. So we have to write complete solution of this given partial differential equation is z is equal to complementary function plus particular integral. In today's video we will cover complementary function, how to find complementary function of partial differential equation with constant coefficient. In next video we will start particular integral, and then we will take some problems. Okay, so first we will take complementary function. What is complementary function? Means suppose phi of d dash into z is equal to f of xy, or this is the given linear partial differential equation with constant coefficient a, and we have to find a complementary function of this. So first in this phi of d in d dash, phi of d dash is the polynomial in d. So in this equation first we have to put d equal to m and d dash is equal to 1. So listen carefully, this step is new step here. You have to put capital D equal to m and d dash is equal to 1. Then how we write auxiliary equation using equation 1? Means in equation 1 if you put capital D equal to m, d dash is equal to 1, then this can be written as a0 m raised to n plus a1 m raised to n minus 1, because d dash की value क्या है 1, plus so on plus an is equal to 0. So this is the auxiliary equation. Auxiliary equation क्या लेते थे हम? phi of d equal to 0. Same here we have to take auxiliary equation phi of d dash is equal to 0, and in that put d equal to m and d dash is equal to 1. Okay, now this is the auxiliary equation. Degree of this equation is n, so it has total n roots. Suppose now how we write complementary function using roots again. Okay, suppose m1 m2 mn be the distinct roots of this auxiliary equation. m1, m2 up to so on mn, these are the distinct roots of this auxiliary equation, then complementary function can be written as f1 into y plus m1x plus f2 into y plus m2x plus so on plus fn into y plus mnx. Okay, where f1, f2, mn are arbitrary functions. So when we use this formula for complementary function, if roots m1, m2 up to so on mn are distinct roots, okay, then suppose m1 equal to m2 equal to mn, means all roots are repeated, means suppose m1 1a subroot 1 1 1a, means that root is say m, okay, means let root m repeated n times, then complementary function, how we write? Complementary function is equal to f1 into y plus mx. Why we write here mx only? Because repeated root है, वही root आएगा. So f1 into y plus mx plus x into f2 into y plus mx plus x square f3 of y plus mx plus so on plus x to the power n fn of y plus mx. Okay, so this is the formula. When m is repeated n times, then we can write CF using this. Okay, so these two formulas are important, how to find complementary functions. So when we use this, if or when we put d is equal to d equal to m and d dash equal to 1 in auxiliary equation, only when d dash is not common factor of phi of d d dash, means ये जो phi of d d dash इक्वेशन है, इसमें हम d इक्वल टू m d dash इक्वल टू 1 कब पुट कर सकते हैं? only when this d dash is not common factor of phi of d d dash. अभी जब प्रॉब्लम लेंगे हम उसमें पता चलेगा आपको. if it is so, means suppose if we take d dash common from phi of d d dash, then we will take d dash common and then put d dash is equal to 1 in remaining factors of phi of d d dash. Means for example, suppose phi of d d dash equation is d square d dash square plus d d dash equal to 0. So from this we can take d dash common. If we take d dash common, then remaining terms can be written as d square d dash plus d equal to 0. In such cases we can put d is equal to, when we put d equal to m, here put d equal to m and d dash is equal to 1 then. Okay, and we have to take d dash common. यदि d dash common लिया तो उस टाइप के यहाँ से d भी common आता है. यदि इस टाइप का प्रॉब्लम आया तो CF कैसे लिखेंगे? सो इन सच केसेस CF will be first, if suppose d is the only common factor, means in auxiliary equation suppose d is only common factor, then CF is in terms of y आएगा, f of y आएगा, बिकॉज कैपिटल D क्या होता है? डाबा z बाय डाबा x. यदि d कॉमन आया तो जो CF रहेगा वो in terms of y आएगा. If d dash is the only common factor, then CF is f of x. यदि d कॉमन आया, d dash कॉमन आया तो कैसे लिखेंगे हम CF? that is third step. If d is repeated n times, means suppose d कॉमन लिया हमने, power of d is n, means suppose ऐसे रूट आए d equal to 0 0 0 0 n times or d equal to 1 1 1 1 n times. If d is repeated n times, then means d raised to n common लिया. Okay, then CF, how we write? CF in terms of y we have to write, and CF is equal to, formula is f1y plus x into f2y plus x square into f3y plus so on plus x raised to n into fny. If d dash is repeated n times, then CF is f1x, because CF in terms of x रहेगा, that is f1x plus y into f2x plus y square into f3x plus so on plus y raised to n into fn of x. So this is related to CF. Now we will take some problems on complementary function only. So first problem is solve 2 into dabba square z by dabba x square plus 5 into dabba square z by dabba x dabba y plus 2 times dabba square z by dabba y square equal to 0. Here right hand side is 0, so we know that solution of this partial differential equation with constant coefficients, where coefficients are constant, so with constant coefficient is complementary function plus particular integral, but right hand side is 0, so particular integral is 0, so only complementary function is the solution of this partial differential equation. So using first capital D is equal to dabba z by dabba x and d dash is equal to dabba z by dabba y, we have to write given differential equation, that is 2d square plus 5d d dash, because here dabba z by dabba x, dabba z by dabba y, and plus 2d dash square into, we can take z common from this, is equal to 0. Okay, so this is using capital D is equal to dabba z by dabba x and d dash is equal to dabba z by dabba y. Now here we have to write auxiliary equations, we have to put, इस यहाँ से कॉमन नहीं आ रहा है, देखो d भी कॉमन नहीं आ रहा है, d डैश नहीं कॉमन आ रहा है, so we can put here d equal to m and d dash is equal to 1. So if you put d equal to 1, d dash is equal to 1, d equal to m, d dash is equal to 1, then auxiliary equation आएगा 2m square plus 5m plus 2 into z equal to 0. So auxiliary equation is equal to 2m square plus 5m plus 2 equal to 0. So what are the roots of this? You can find roots of this using calculator. So roots are here, m equal to minus 2 and minus half. So roots are distinct, minus 2 is not equal to minus half, and therefore solution of given the partial differential equation is z is equal to cf. If roots are distinct, then how we write here m1, m2, mn with the distinct roots, then how we write complementary function, that is f1 of y into m1x plus f2 of y into m2x. So take m1 is equal to minus 2 and m2 equal to minus half. So solution is f1 of y plus m1x minus y minus 2x plus f2 of y minus x by 2. Okay, or we can write this solution as f1 of y minus 2x plus f2 of 2y minus x, this way also. Okay, so this is the complete solution of this differential equation. So next problem is solve dabba square z by dabba x square plus dabba square z by dabba y square plus 2 into dabba square z by dabba x dabba y equal to 0. So using again capital D is equal to dabba z by dabba x and d dash is equal to dabba z by dabba y, how we write this differential equation? This can be written as d square plus d dash square plus 2 times d dash into z equal to 0. Again right hand side is 0, so only complementary function is the solution of this partial differential equation. So we have to put here d is equal to m and d dash is equal to 1, then we can write auxiliary equation is equal to m square plus 2m, because d dash is 1, and plus here 1 equal to 0. So what are the roots of this? This is m plus 1 bracket square equal to 0, means m equal to minus 1 minus 1. So m equal to minus 1 are the roots, means second case for complementary function we have to use. Therefore solution of given partial differential equation is z is equal to, so we have to use second case of cf, that is f1 of y plus, means m is repeated roots n times, then we can write f1 of y plus mx, m is minus 1 here, plus x into f2 of y plus mx. So this is the solution of given linear differential, given partial differential equation with constant coefficient. Then third problem is solve dabba cube, or solve in terms of d लिखेंगे directly, d cube into d dash square plus d square into d dash cube z equal to 0. Okay, so this is a given partial differential equation and we have to find solution of this. Now observe this phi of d dash carefully. Here we can take d square common, also we can take d dash square common, means if you write suppose given partial differential equation as d square into d dash square, by taking d square and d dash square common, in bracket remaining terms are d plus d dash is equal to 0. Means here we cannot put d equal to m, d dash equal to 1 directly. Why? Because we can take d square and d dash square common from this. Now if we take common, then in remaining part, means in this equation put d equal to, मीन्स here देखो d स्क्वायर यहाँ से क्या आएगा, d स्क्वायर इक्वल टू 0, d डैश इक्वल टू d डैश स्क्वायर इक्वल टू 0 एंड d प्लस d डैश इक्वल टू 0. सो यहाँ से मिला हमें d इक्वल टू 0 0, हियर d डैश इज इक्वल टू 0 0 एंड हियर we have to put d equal to m and d dash equal to 1, then we will get auxiliary equation m plus 1 equal to 0. So from this we get m equal to minus 1, and therefore how we write complementary function? Then z is equal to, if d square is common or power of d is common, then we have to write cf in terms of y. Okay, so z is equal to cf क्या आएगा, then f1 of y 2 times repeated a plus x into f2 of y. Okay, and plus if d dash is common, then we have to write cf in terms of x, so plus f3 of x and plus y into f4 of x and plus m is equal to minus 1 is 1 root, so this is f5 of y minus x. So this is the complementary function of given partial differential equation with constant coefficient. So these are the some problems on complementary function, means how to find complementary function of partial differential equation with constant coefficient. In next video we will take a particular integral, and then we will take problems on complementary function plus particular integral, means that is the complete solution of partial differential equation with constant coefficient. Thank you.